it.
So 2.5 plus 2.5, so this is the same. We get 2.5, so you add those together to get 5. So AB is equal to 5.
Thank you. John, tell us, do you agree or disagree?
I agree.
All right, here's my question. How did you know that they were going to be congruent, that both of those were going to be 2.5?
2.5, I don't know. I just put 2.5.
Okay. Can anyone tell us, how did we know that those were going to be congruent?
Equal sides and a right angle.
Yeah, there's a right angle right there. Also, AC and CB is congruent, which means C is equidistant to A and B, which means that the line T is a perpendicular bisector. And bisector means it goes through the midpoint. So if it goes through the midpoint, that means both sides would be the same. So both sides would be 2.5, so therefore AB is 5. Perfect.
I didn't see those lines at all.
Yeah, you're good. What questions do you have on the bell ringer? You can put your bell ringer away. I need you to get out your 8.1 worksheet that I gave to you, and then I need you to get like a pen, a marker, colored pencil, something that stands out that's not a pencil. And I need you to make corrections. Make sure you make corrections on your paper if you got the wrong answer.
Got me one that.
All right, so on the front page, you just had to explain whether or not point P was on either the perpendicular bisector or the angle bisector, and you had to explain why it was or why it was not. Now, my number one, I had written down the explanation, but then when I was looking at it, I was like, oh man, no, that's wrong. But then I looked at it again, I was like, oh wait, no, never mind, it was right. So then I rewrote it. All right, so now your explanation might not look exactly like my explanation, but it should be in the same vicinity. So number one, the answer is yes. Let's pay attention, please. It is on the perpendicular bisector. And how I knew that was because there's a right angle, which means that the line TP is perpendicular to the line RS. And I knew that because of the right angle. And then also, they didn't have a point there where they intersected, so I just made up a point B. RB is congruent to BS. Okay, so since these two are congruent, and since that's perpendicular, the answer is yes. You could have also said yes because T is equidistant to the endpoints R and S, because those two are congruent. Number two is yes, and that's because T is equidistant from endpoints R and S. TR is congruent to TS. Number three, this is an angle bisector, and how I knew that was because DP and PF are congruent, which means P is equidistant to the sides of angle DEF. Number four, you cannot say it because the line PQ is not marked perpendicular to the segment RS. So it would need to be marked perpendicular.
I put no because there is not a 90-degree angle.
The same thing. 90-degree angle means they're perpendicular. Number five would be no because there's no indication that DP and PF are congruent. So I would either need to have these two sides marked congruent, or I would need these two angles marked. And since neither of them are marked, I cannot say that it's an angle bisector. Now, number six, the angle bisector is of this angle DEF. So you got to figure out if this line is an angle bisector of this angle here. Well, this side and this side are congruent, and these are right angles, which automatically makes these two angles congruent. And then this makes these two triangles congruent, because if these two angles are congruent and these two are congruent, then that automatically makes the third angles congruent by third angle theorem. So therefore, this would be an angle bisector. But I just put yes, DE is congruent to EF, and angle QDE and angle QFE are right angles. Okay. So that was how I put it, just because these two are marked congruent and you have right angles. So that makes it the angle bisector. Okay. What questions do you have for me on the front page? Or on how to determine if something's an angle bisector or a perpendicular bisector? Okay, all right, turn over to the back page. Number 7, you should have gotten 20. Number 8, you should have gotten 14. Number 9 is 7.3. Number 10, you should have gotten 14.6. 11, you should have gotten 56 degrees because ABC, the entire thing is 112. And if these two are congruent, you just divide by 2 and get 56 degrees. 12, you should have gotten 126 degrees. Now, 13 had 2 questions. First, it asked you is point Q on the perpendicular bisector. Then it asked you is point S. Well, right now it's not on the perpendicular bisector, but these arrows mean that the lines keep going on forever. So they're saying whenever this line crosses through here, is it going to cross through point Q? And whenever it keeps going this way, is it going to go through point S? Well, this is the perpendicular bisector. It's perpendicular, and it goes through the midpoint because these two are congruent. So what you want to look for is whether or not Q and S are equidistant to the endpoints P and R. Well, if you look at Q, from Q to P is 13 units, and from Q to R is 12 units. So since it's not equidistant, it's not going to be on the perpendicular bisector. So for Q, the answer is no, and it's because segment QP is not congruent to segment RQ. If you were to extend this line, it would actually go over Q a little bit. But then look at point S. From S to P is 10, and from S to R is 10. So if I were to extend this line, it would go straight through point S. And that's because the segment PS is congruent to the segment SR. It's equidistant to the endpoints, which means it's going to be on the perpendicular bisector. This one's not the same, so it's not going to be on the perpendicular bisector. Okay. All right, what questions do you have for me? All right, you're going to want to keep this worksheet because your homework assignment tonight on Big Ideas Math, it's 8.1 practice. It is a lot like this worksheet. So you're going to want to use this worksheet in your notes for the Big Ideas assignment. The Big Ideas assignment is going to be your homework assignment, 8.1 practice, and it'll be due at the beginning of class tomorrow.
Will we have time to do that in class?
Possibly, depends on how far, if we finish the notes.
Is this the notes right here, just this?
Yes.
Oh, yeah, we'll go.
Okay. 8.2 notes. Bisectors and triangles. 8.2 notes, bisectors and triangles. So we reviewed perpendicular and angular bisectors. Now we're going to talk about those. Okay. So there's been some discussion. There's been some discussion. Here's a map of our school buildings. There's the high school. There's the football field, the BEC Southwest. There's the admin office there in the middle. There's middle school, and over here Central Elementary. Well,
Southwest.
Yeah, sorry.
And West
Rock Orthodontics.
Where's the baseball?
Tennis court. You
It's
forgot
all
the
the way
tennis court.
across town.
All right, so there's been some discussion about them building a storm shelter for all the schools to go to. Well, the high school, Southwest, and Central have been competing and saying it's not. They want it to be closer to their place. Like they don't think that they should have to walk that far. So at the central office, Mrs. James and Mr. Miller have been trying to find a location to put the storm shelter.
Is this real?
So that way Southwest, the high school, and Central can all walk the same distance. Okay, so there has been talk about it, yes.
Put it in middle school.
So Mr. Cruz, he could care less. He said, do whatever you want to do. All right, but so they're trying to find a location where the Southwest students, the high school students, and the Central students all walk the same distance to the storm shelter. Like it's like pretty much right in the center of the three schools. It would be the same distance from the storm shelter to all three schools. By the end of today, you will be able to tell Mrs. James and Mr. Miller where they need to put the storm shelter.
Put it in the orthodontist.
Put it in the BEC. We'll know what.
Put it in the BEC. Well, then it'd be closer to high
So we
school.
destroy all them houses right there, them people live in, just put it right there.
All right,
Probably
so
the best option.
the first thing we're going to do is we're going to construct perpendicular bisectors of each side of the triangles. Now, there are a few steps in order to construct a perpendicular bisector. Okay, so you'll want to make sure I will do the steps very slowly, and then I will do the steps again a little bit faster. So, but you'll just need to make sure that you're following along and doing the exact same thing I'm doing. All right, so here's what I need you to do.
I'm not good with these things.
I need you to loosen up this by twisting it, and then you can slide it. And you need to open up to where this hole right here is a little bit more than halfway of this side of the triangle. So I would do it about 2/3 of the way. I would open it up about that far. And a way to make this easier on you, on your paper, if you see the three vertices of the triangle, the three corners, put a dot there, and that will tell you where to put your dot from the compass. So put a dot at the three corners of the triangle, the three vertices. Now, do you see that little dot in the center of the clear circle?
No.
Okay, there's an X, and then there's a little bitty dot there. Put that dot on top of the dot you made right there.
I can't see that well.
Okay, so that center circle dot should be on your dot. Once you get it there, take this right here, the sliding scale thing, and open it up so that way it's a little bit more than halfway. I would open it up to where it's pointing at 2.5 centimeters, personally. So put the dot on the dot.
Oh, wait.
And then open this up here to where you see that pointy triangle thing, make it point to 2.5 centimeters. Now, once you get it positioned, take your finger and press it firmly on that center part, just the clear part. Do not push on the red. Just push on the center. And then take your pencil. It's better if you don't have a mechanical one, but if you have a mechanical
I'm
one,
left-handed.
Yeah, we're left-handed.
Andrew. Okay.
if you have to, you can probably turn your paper around.
No, I'm gonna do it like this.
Okay.
My little boy.
All right. Make sure it doesn't move from that dot. Now take your circle or take your pencil and put it in this inside circle and draw you pretty much like a half circle like that right there. I wouldn't draw very darkly, but you just swivel it back and forth and make you about a half circle.
Andrew.
I don't move like that.
Mr. Brooks.
Mine
Actually pretty good.
was like 3 lines.
It's good, man. This ain't my fault.
That's okay.
Yeah, it is.
Hey, now you'll be at an advantage because now what I need you to do not move the middle part. Leave it alone. You should have it locked into position. But now take this center part and put it on this circle over here or this dot here on this other side.
I turn my paper.
You can turn your paper
Cool.
and take it and
Do the same thing.
hold it down and put this on the inside dot closest to your finger and then do the same thing.
I made circle. I can't do that. Turn the paper. I've been trying.
Screw it. I can do
Yeah,
that.
if you're at home watching us do this, it's unless you have your own compass, it's going to be hard to do this. So you're just going to want to kind of follow along.
But Can I just follow my thing?
No, not when you're in class.
Can I color in the middle part?
No, not yet. Or no, you don't want to do that. All right, so let me walk you through the steps again.
I hate these
You
things.
should have a circle there or a dot, and you put this dot here and hold it down. And then make sure this is on 2.5, 2.5. Put your pencil in there and make a circle. And then once you do that side, turn it around and do this other side. Put your finger on the center part. Put this in here and make another half circle. Do not let your compass move.
How do your compasses spin? Mine don't spin. It just stays on
Bring it to me. Let me see it.
It's too strong.
I had one earlier that was messed up. That needed like loosening up, and I was able to fix it. But then I had another one that I was not able to fix.
Not circles. You don't do complete circles.
Okay, so let me do that. Yeah, you're going to want to get a different compass. Get you a different one because this one's sticking. All right, now here's how you would figure out where to draw your perpendicular bisector. You see this point here at the top where the two arcs intersect? Put a point there.
So we don't draw 3 circles? Yeah.
No, well, you will. So put a point right there. And then down here at the bottom, put another point. And then your compass is also a ruler. So what you're going to do is draw a line that goes through the 2 points. Okay, so I drew a line that went straight through those 2 points. Pay attention. And then once you draw that line, I would go through and erase your arcs so that way they're not that dark.
What the heck?
And what you have done now is you have drew a line.
I use color.
You have drawn a line that is perpendicular to this side, and it cut this side in half, which means this side is congruent to that side.
So we did all that work just to make it straight. I could have made a straight line.
But you know it's perpendicular. It meets at a 90-degree angle, and it cuts it in half.
Does it have to be perfect?
If you follow the steps, it will be perfect.
So we have to do this in every problem we do now?
No.
Okay.
On today's notes we do, but not today.
Yeah, I don't know if I can be able to do this. Every time I try to do it. This one ain't sticky either. Look, it flops all around like this, you see? Yeah. But when I push down my paper, it don't turn.
Okay. Once you have that one done, now what I would do is turn your paper. And now we're going to do the same thing to this side. So, first thing you need to do is make sure that it's opened up more than halfway. And that's about more than halfway. That's a little bit more than halfway, so I think we're good. Okay, so
2.5.
yeah, I'm leaving it at 2.5. As long as it's a little bit more than halfway, you'll be good. That way, as long as your 2 circles intersect, you'll be fine. All right, so what you want to do, again, I'm going to go through the steps slowly again.
Come on.
Take this circle and put it on the dot you made, and put your finger down and hold it firmly. And then take your pencil and stick it into the hole closest to your finger and make a half circle.
Why is mine so big? I mean, I'm going around the whole paper. Look.
Then put it on the other dot, on the other side of the triangle. Press your finger down firmly on the clear part and stick the pencil in the hole and draw your arc.
You guys can have some of this. I'm not using that.
Once you do that,
My compass don't work.
take these 2 points and draw circles where those plot points where those 2 arcs meet at the top and at the bottom. And then take your ruler and connect and draw a line that connects those 2 points, but make it go all the way through.
If we just go like 3 circles and whatever goes over, if that's the answer.
You're going to draw 3 circles, but then people get confused about which 2 dots to go through when we draw all 3 circles at the same time.
Right, no way I can do it.
Okay?
Because that's how I did first, just all 3
Now I'm going to erase these arcs because I've got one more to do.
You might not look at all the dots, but looks good. You got it.
So now I'm going to turn my paper to this. Oh, sorry guys, I forgot to tell you that now that you drew this line is perpendicular to that side, and this side is congruent to that side.
Oh, Miss Kim, I got a question.
Yes.
Do we have more points than any other class?
Mm-hmm. You and first hour are pretty close.
What's next after the pizza party?
I have to think of stuff for you to do because I didn't have anything past 500.
Yo,
Fun.
I'm down. I'm scared of heights.
All right, now let's do the third side.
Put it up, right?
All right, so we're doing the same thing again. Put your dot on the corner of the triangle on the vertex and put your finger down. Put your pencil in the hole closest to your finger and draw an arc. Then turn it over. Put your finger down. Put your pencil in the hole and draw your other arc. And then plot your 2 points, this point and this point. And then draw a line through those 2 points. And then you can erase your arcs. Okay. Now what that means is you've just drawn a line that's perpendicular to this side, and then it cut it in half. So this segment's congruent to this segment. Okay. So each of my sides have been cut in half by lines that are perpendicular. We just constructed 3 perpendicular bisectors.
You think we do the next one?
We're going to do the next one together. Okay, let's do the next one. First thing you need to do is put a dot at the 3 corners. Okay. Then take your compass and make sure it's opened up more than halfway, and it is. Put the dot in the center of the clear circle on the dot on your triangle and put your finger on it. Put your pencil in the hole closest to your finger and draw a circle. Now, something that Caden mentioned was he went ahead and just drew all 3 circles, and like you can do that and then do like the perpendicular bisectors. Some people get confused by knowing which 2 points to go through, but if you wanted to do that, that's fine. All right, then keeping it at the same setting, place it on that other dot on that side. Put your finger down. Put your pencil in the hole closest to your finger and draw your arc.
Wow.
And then connect the point, or not, the 2 points where the 2 arcs intersect. Put points there and draw your perpendicular bisector.
I think my fingers are too big and strong for this.
Okay. So these 2 lines are perpendicular, and this segment is congruent to this segment over here. And then I'm going to erase my arcs, so that way it's not very confusing. Okay. Now pick another side. I'm going to do this other side of the right angle. Put your compass on the point. Put your finger down. Put your finger in the hole closest to your finger or your pencil. Pick it up. Put it on the other dot. Put your finger down. Put your pencil in the hole closest to the finger. Draw your arc. Look at the 2 points where they connect. Line up your ruler and draw your line connecting those 2 points. I'm going to erase my arcs. And what that means is these two lines here are perpendicular and this segment's congruent to this segment. Okay. Now we have a third side. It's the hypotenuse of this right triangle. So I'm turning my paper around so I have this side at the bottom. Okay. Do it again. Put the dot on the point. Put your finger down. Put your pencil in the hole closest to your finger. Draw your arc. Pick up your compass. Put it at the other side. Put the dot on the point. Put your finger down. Put the pencil in the hole closest to your finger. Oh, no, I didn't check something. I didn't check to make sure it was more than halfway. So I'm going to have to make it a little bit bigger because your two circles have to intersect. So what you need to do is loosen it up and let's make it, let's see, 3. Yeah, 3 should be more than halfway. So let's open it up to 3. And then tighten it up. Now let's do it. Put your dot on the point, put your finger down, put your pencil in the hole, make your arc. Turn it around. Do what?
Yeah, it doesn't matter how big they are.
As long as it's more than halfway, it doesn't matter. And whatever you do whatever you do at this point, it has to be the same at this point. Like you can't do 3 here and then 2.5 here. Like if you do 5 here, you have to do 5 here. If you do 6 here, you have to do 6 there. You have to do the same on both points. But when it comes to the sides, you don't have to do the same because sides are different lengths. All right, so put the dot on the point, put your finger down, put your pencil in the hole, and draw your arc. Now they intersect. So now I can put points where they intersect. And I can draw my line using my ruler through the points. And I'm going to erase my arcs so they don't confuse me that much. Because we do have a lot of drawings on here. And what that means is this line here is perpendicular to this side. And this segment is congruent to this segment because it goes through the midpoint.
Yeah. Friendship.
On both triangles, what do you notice about the perpendicular bisectors?
They all meet in the middle, one's on the side.
Oh, good. One's in the middle of it, one's on the side. Andrew, what were you about to say?
They all have the midpoint.
Yeah, they all intersect at one point. It's called a point of concurrency. And whenever your perpendicular bisectors intersect, that point right here, that is called the circumcenter. The circumcenter. So, and this point here, where they intersect on the side, that is a circumcenter. In every single acute triangle, the circumcenter is on the inside. In every single right triangle, the circumcenter will be at the hypotenuse. And with an obtuse triangle, it's going to be on the outside of the triangle. The circumcenter is kind of like the center of gravity. It's like it's the center. Because your center of gravity might not necessarily be right at the center of the object. Okay, now the next part says, measure the length from the point of concurrency to each angle in the triangle. What do you notice? So what we're going to do, we're going to measure from this point, the circumcenter, to these points of the corners of the triangles, the vertices of the triangle. So take your ruler and let's use the centimeter side. Make sure you're on the centimeter side. Measure from this point of the triangle, from that vertex to the circumcenter. So from the vertex to the circumcenter. How many units is that?
2.5.
2.5. So from here to here is 2.5 centimeters.
Let me guess, it's gonna be 2.5 on every single one of them.
Now measure to another vertex. So let's measure to this one from the vertex of the triangle to the circumcenter. How many units is that?
2.5.
2.5. So that is 2.5 centimeters. What do you think the third one's gonna be?
2.5.
What do you know? From there to there is also 2.5 centimeters. So the circumcenter is the same distance to the corners of the triangle, or to the vertices of the triangle. So even though it cuts the sides in half, it's the same distance to all three angles. Okay? Do you think it's going to be the same case here on this one?
Nope.
Okay.
Perhaps.
Let's try it and see. Let's measure from this angle, from the centimeter mark to this one. How many centimeters would you say that is?
2.5.
I would say it's a little bit more maybe than 2.5, maybe about 2.6. Okay, so from here to here is about 2.6 centimeters. What about from this point?
2.7.
Yeah. My point's a little bit big, and I've got it off center, but mine's about 2.6 also. But my point's a little bit bigger, which made it look like it was at 2.7. Now let's measure from the right angle.
2.7.
That one's also 2.7. So what do you notice about all the measurements from the circumcenter?
Let's look at my keys in the phone caddy.
All right.
What an idiot.
All right, let's pay attention, please. What do you notice about the length from the circumcenter to each angle of the triangle?
Couldn't tell you.
They're close to each other.
Well, like, what do you notice about all three of these?
Oh, it's all the same length.
What do you notice about all three of these?
They're not all the same length.
Well, this one here, it was off a little bit, so let's put 2.6.
All the same length.
They're all the same length. So the circumcenter is the same length, or the same distance away from each angle of the triangle. Okay. So if you wanted to find the center of the three angles, the place that's the same distance away, you would just need to construct the circumcenter. And you construct the circumcenter by constructing perpendicular bisectors and seeing where they intersect.
Bless you.
Okay. All right. Now let's go over to the back page. Now we're going to construct angle bisectors. Angle bisectors. It says construct the angle bisector of each angle of the triangle. So the first thing you need to do is put a point at each of the vertices of each of the triangles. So that way you know where to put your compass.
So we need a professional tractor for this.
You will need your compass. Now, I suggest taking your compass and closing it to the smallest setting possible, sliding it all the way over and then tightening it up.
So 1.2.
Yes. Slide it over as small as you can. Okay. After you get as small as you can, take that point and put it on the point that you drew at the vertex of the triangle. Put your finger down. Use your pencil and stick it in this hole closest to your finger and draw your arc. It needs to go through both sides of that angle. So it needs to look like that. Okay. All right, so you need to be doing this as we do it because it can get a little confusing. Now you see these 2 points where they intersect at? Put you a point there and there. Put you a point on each one where they intersect.
Oh.
Then you're going to do the same thing, but you're going to do it from this point and this point. So put this center circle on your point up here. Put your finger down. Put your pencil in the hole and draw an arc. So you should have another arc outside here. I did it from this one. So I put it right there on that one, and I put my pencil in and drew an arc. Now do it from this other point you made. And these two arcs should intersect. These two arcs should have intersected. Where they intersect at, put a point there. And then take your ruler and draw a line through the vertex all the way through this point through the other side. So line up those 2 points there and draw your line. That is an angle bisector. What that did was it cut this angle into 2 congruent angles. And then once you're done, erase your arcs because we're going to have to do it at all 3 angles. Okay. All right, so there's your first angle bisector.
It is.
No, this class goes by so fast.
All right, are y'all okay if I go ahead and do the second angle?
Sure, go ahead.
Okay. Now I'm going to put it on the second angle, and I'm going to place my finger on the hole. Put your pencil in the hole right next to your finger and draw the arc. And then where it intersects the sides, put your points there. And now you're going to put your point on the 2 new points one at a time. So put it on the first one, hold it down, draw an arc using the hole closest to your finger. And then do it from the other point that you made earlier. And at the same thing, draw an arc. And then you're going to put a point where those 2 arcs intersect. And then you're going to use your ruler and you're going to draw a line from the vertex through that point. Now that is an angle bisector, which means this angle here is congruent to this angle here. What other? Are you talking about the perpendicular bisectors?
Yes, but not real half circles.
You can draw them as big as you need to. I just draw them just big enough as long as I'm good.
It's just a lot of circles.
All right, and now we got to do from the third angle, the angle bisector. Okay, so put your compass on the point, put your finger down, put your pencil in the hole and draw an arc to both sides. Put your points where they meet at. Put that right on one of the points. Hold it down and draw an arc. Then do it from the other side on that point. Put your finger down, put your pencil in the hole and draw an arc. Do the point and then draw your line, draw your angle bisector through those 2 points. And then you can erase your arcs so that way it's not very confusing. And then that means that this angle, which my line's off a little bit, that's why it's not matching up. You can see I went to the left of the point a little bit. These 2 angles are congruent. Now, we're going to not do number 2 right now. The point of concurrency. What do you notice about the point?
They are close to the other ones.
Yeah, they should all meet up at the same spot. Mine doesn't, but that's because my line's off a little bit. This point is known as the end center. The end center. Okay. And something special about the end center, if you were to measure from the end center to the side of the triangle, that's about 1.5 centimeters. So from here to here, that's 1.5 centimeters. And then if I were to measure it to this side of the triangle, that's also 1.5 centimeters. And if I were to measure to this side of the triangle, that one's also about 1.5 centimeters. So the special thing about the end center is that the end center is is the same distance from each side of the triangle. So the circumcenter is the same distance to the angles. The incenter is the same distance to the sides. So the sides would represent, like if you had, like if these were roads and you were trying to build a lamp post in the center that was the same distance to each road, you would find the incenter. On our problem that we were discussing earlier, if you were to connect the high school, Southwest, and Central Elementary like they were a triangle, you can construct the 3 perpendicular bisectors and find out where the circumcenter is, which is going to be right here in this group of houses here. And that's where you would build your storm shelter, is where the circumcenter is.
Freaking called it.
Did we destroy them buildings?
Can we get our phones in?
Just a second. All right. You will don't forget, you have 8.1 practice on big ideas for homework. It's due tomorrow. You will do this last problem tomorrow for notes, and then you will have a few more notes to take along with a couple practice problems.
Yes, ma'am.
What questions do you have for me? All right, you can put up your calculators, get your phones.